Let's see how Solid Edge with synchronous technology addresses one of CAD's most difficult operations, shelling. Using a built-in command finder, watch as we enter shell and the appropriate Solid Edge command called thinwall is returned. Imagine how fast you'll learn Solid Edge with this handy tool, as you simply type in a command name you're familiar with and the correct equivalent is found. The main challenge with shelling in a history-based CAD system is that the operation must be done at a specific point in time. Also, shelling must be done early in the process so items like stiffening ribs can be added afterwards. This complicates creation as users must carefully plan how models are constructed. To make matters worse, a simple edit such as a thickness change forces a complete model rebuild. We'll add some stiffening ribs, starting with a sketch retrieved from a library. Because thin wall operations in Solid Edge are procedural, users have full edit control without model regeneration. As we taper the vertical face, notice how wall thicknesses and symmetry are preserved. These edits happen without regenerating the entire model, but in a history-based system, this simple change would force a costly rebuild on the entire shell and rib operations. Another key aspect of Solid Edge with synchronous technology is that features aren't dependent on each other. Watch as we edit the resulting face of the thin wall operation to change the part's shape. It doesn't matter what geometry or features are selected. Notice how we can choose a mounting hole and drag the model into shape using a handy grab-and-go handle. Imagine being able to move a mounting hole into the correct location and have the model follow that change. Another powerful capability of Solid Edge with synchronous technology is that you can add as many thin wall operations as needed. This capability eliminates the amount of pre-planning engineers need to invest in making flexible models that can accommodate last-minute additions and future changes. For example, the initial requirements didn't call for a mounting foot, so it wasn't added. While it can be added in a history-based system, reordering would be required to position the new feature before the shell so it gets hollowed out. Because you can add additional thin wall operations in Solid Edge, users have total design flexibility by making adjustments along the way without having to worry about managing a complex sequence of steps. Thin wall operations are procedural, so you still have edit control without complete model regeneration. Watch as we change the wall thickness and the model instantly updates. Because of this technology, larger, more complicated models will also update with the same nearly instant speed. To further demonstrate this fast performance, let's make a change to the entire model. Since the part is just roughed in, we can modify the arm by moving one of the original mounting holes. As the edits are made in real time, see how the model stays symmetric and the wall thicknesses are maintained. While these are free drag changes, dimensions can also be added to control model size. Here, we will add a dimension to a resulting face of the thin wall operation. And because features are not dependent on each other, the dimension can change either the height of the mounting arm or modify the depth of the thin wall, which ultimately changes the arm height. We'll make one last edit to increase the overall height of the center section, and a quick grab and go shows the simplicity. The intent is to maintain the size of the upper face, and to preserve that notion, an option is available to do just that. Notice how the side faces rotate to accommodate the change. That completes the design of our new part, so let's see how it fits with the rest of the bike. While we made some interesting edits to the mounting arms to show edit speed and flexibility, let's move the mounting holes into position. Assembly level edits can be made by dragging part geometry to an exact location using key points of other components. Dimensions can also be added and used for precise control. Solid Edge with synchronous technology is the only system that has taken complexity out of complex part design.